Alright, so this is WriteUp 9. It is another BR struct visitor. This week we will be returning the number of strings in the BR struct which both start and end with a vowel. So every time that we see a string in this tree, we are going to add it to our count. Every time that we see one that doesn't, we will just add 0 because that adds nothing. The condition which we are looking for is that a string both starts and ends with a vowel. Rather than trying to figure all of that out in our empty case and our non-empty case, we can just create some helper methods that'll help us out. So the first thing that we care about is we're wondering if a character is a vowel or not. So we can write a isVowel method that should be able to help us out with that. So public boolean isVowel. So this will just take in a character C and return true or false. It'll return true if that character is a vowel, and it will return false otherwise. We don't have to worry about capital letters or sometimes Y because Dr. Alphonse gives us the 5 characters that are counting as a vowel for this write-up. So we will return C is equal to A, or it's equal to A, or if C is equal to E, or C is equal to I, or C is equal to O, and finally, or if C is equal to U. So if any of these conditions are true, this function will return true. Obviously C can only be one character, so it can't be multiple of these. It only has to be one of them, and as soon as one of them is true, the whole function becomes true because this whole statement becomes true. Alright, moving on. So we're going to utilize this function in figuring out whether or not a string both starts and ends with a vowel. Creating a function like this should be pretty basic at this point. It would have been a good write-up for like week 1. So let's think about writing a function that takes in a string, returns true if it starts and ends with a vowel, returns false otherwise. So instead it returns true or false, so boolean, and we'll say that this is a valid string if it follows these conditions. So it takes in a string S. We're going to look at the first character of the string, and we are going to look at the last character of the string. So in order to get the first character of the string, you can say s.char at 0, and we want to check if this character is a vowel. And since this returns true, we can just return this value. So what this does right now is it checks to see if the character at the first index of string S is a vowel, and if it is, it returns true. But we don't just care about the first character, we also need that last character to also be a vowel. So we will check if the last character is a vowel. In order to get the last character, we'll get the character at some index, and that index is going to be the length of the string minus 1, because as you remember, the length of the string is the last index plus 1 because indexing starts at 0. So in order to get the last index, we will take the length and subtract 1. Okay, so now we have this valid method. This will be useful because now we can just call that method on any string, which would be any node, any datum value in our tree, and we can call that function on any string and see if it starts and ends with a vowel, it will return true, and if it does not, then it will return false. So if valid is true, then we want to add 1 to our final result, and if it is false, then we want to add 0 to our final result and keep running through our tree. So in the empty case, we're going to return 0, since we are adding a bunch of values together, and since something plus 0 is just itself. So our empty case will do nothing but add 0, and then return so that we can recurse back up the tree. In our non-empty case, we have two cases. We have either that the current datum that we are at, not the current datum, the current node that we are at is either a valid string or it is not a valid string. So if it is a valid string, here's what we will do. So first we're going to check if our current value is valid. Our current value is just host.getDatum. This will return the current string that we are at in our tree. If that is valid, then we will return 1 plus host.getLeft dot execute this plus host.getWrite dot execute this. Otherwise, what do we want to do? So otherwise, we're not adding that value to our final result, and we can just look at the left side of our tree and add that to the right side of the tree. Execute. And this. And if not is. Alright, so now that we've fixed my silly syntax errors, we can see that if host.getDatum, so if the current value that we are at, if that string is valid, we'll add 1 to our final result, and if it is not, then we will just keep traversing the rest of the tree. So let's make sure this runs really quick because I messed up my last run through and I don't want to have to start over again. Alright, so we are good. I will now explain why this works the way it does. Alright, so now that we have this, we can think about an example tree. If you're still not convinced that this is the answer or how we got here. So say we look at our root node. Given that it's not empty, host.getDatum will return a string. We want to check to see if that string is valid. If it is, then we're going to add 1 to everything on the left side of the tree and everything on the right side of the tree. So we're returning 1, and then we are looking at the left side of that node. So we'll move down to the next value, and then we'll start the process over again. We'll see if it's empty. If it is, then we just return 0, hop back up to the node that we were previously at, and then move on down to the right-hand side. Otherwise, we would hop into the non-empty case, see if it's valid, and then if it is, we'd be right back where we were, and we'd be going to the left of that node, and adding 1 to our final value. If this was an empty, or if this was not a valid string, then we would just be moving on to the left and not adding anything. This statement is actually the same as saying return 0 plus host.getLeft.execute this plus host.getRight.execute this, because you're just adding 1 to your final value. If that string is valid, you're adding 0 to your final value if it is not, and then you're performing the same operations on both the left-hand side of that node and the right-hand side of that node. An important thing to remember also is that the order in which you perform these operations does not matter. So addition is commutative, right? So it doesn't matter if you add your value from the left-hand side, then 1, then your values from the right-hand side, or if you go right, then left, then you add your value. That just changes the order in which you traverse the tree. So if you remember going over tree traversals in class, the only thing that would change in that case is if you were drawing out an example of what your tree looked like and then what your stack looked like, the order in which you looked at each element and the order in which they were operated on would change, but your final answer would not be affected. So for instance, say I changed this around a little bit. Our answer should stay the same. It does, right? So, I guess the point to me saying this is not to just memorize that you're always going to the left, then you're going to the right, returning the value that you would get, going to the left, going to the right. That could change. That's just the order in which you're accessing each element in the tree. The only thing that really matters is that that you're adding what you would get from the left element, what you would get at your current element, and what you would get on the right. That you understand the recursion and the order in which you are accessing these elements, and that you understand what value is being returned. So that is all I have on this write-up. If you have any further questions, be sure to come to office hours. They've been pretty empty all semester, so we would be more than happy to help you out. Good luck with the rest of the semester.